なんだあれは。
信じられない。こうも早く。
All right, men, pull her tight. Secure that clamp now.
Watch the far bank. Keep moving. Let's go.
January 1944. Dense morning mist clings to the banks of the Matanakaw River in the Pacific. Japanese soldiers crouch behind tangled mangroves, rifles ready, hearts pounding. The river, swollen with recent rains, carves a natural barrier, its currents wild and unpredictable. For weeks, these troops had assumed the Americans would be stalled here, slowed by nature itself. Then, through the haze, shapes begin to emerge. Steel gleams under the weak sunlight. Long, rigid lines stretch across the water, supported by massive pontoons. Bridges, American bridges, rising seemingly out of nowhere. The Japanese watch in stunned silence. The whispers among them are nervous, incredulous. How so fast? Every officer and soldier senses the implications. Where they expected delay, the Americans have prepared a path. Where they thought nature would hinder an attack, ingenuity has carved a route. The river, once a shield, now becomes a conduit for the enemy. Across the waters, engineering triumph meets tactical surprise. Across the minds of Japanese troops, disbelief and dread ripple silently. It is a moment where steel meets strategy, and the war shifts quietly but irrevocably at the edge of a river. By early 1944, the Pacific War had reached a critical phase. The Allied forces, spearheaded by the United States, were executing a relentless island-hopping campaign aimed at bypassing heavily fortified Japanese positions while securing strategic points for airfields and naval bases. Every island, every river, every coral-strewn inlet represented both an obstacle and an opportunity. Japanese defenders had become masters of the terrain, exploiting natural barriers, jungle thickets, mangrove swamps, and swift rivers to slow, confuse, and destroy advancing American units. Rivers in particular had emerged as tactical choke points. In New Guinea, the Matanakaw and other waterways forced attacking forces to concentrate in narrow, exposed areas where machine guns, mortars, and snipers could inflict devastating casualties. In the Solomon Islands, Japanese troops had entrenched themselves along riverbanks, laying mines and booby traps in anticipation of amphibious or overland assaults. Commanders relied on maps, reconnaissance, and careful observation, confident that the natural environment would buy them time. Time was critical. Each delay allowed reinforcements to arrive, supplies to be stockpiled, and positions to be strengthened. For the Americans, these riverine obstacles demanded innovation. Conventional pontoon bridges and temporary wooden structures were slow to construct and often destroyed by enemy fire or flooding. Early attempts had proven costly in both lives and time. Engineers found themselves racing against not only the currents, but also Japanese artillery and sniper fire. The ability to quickly deploy reliable crossings could mean the difference between a stalled offensive and a decisive breakthrough. The U.S. Army Corps of Engineers had long anticipated such challenges. By 1942, specialized bridge units, known as Engineer Combat Battalions, were trained in rapid bridge assembly under fire. They practiced constructing steel, Bailey-style bridges and floating pontoon structures capable of supporting tanks, trucks, and artillery across rivers that, to an unprepared enemy, seemed impassable. Training exercises simulated Japanese ambushes, flooding, and unstable riverbanks. By 1944, these units had perfected the art of turning a river from a barrier into a thoroughfare, often in a matter of hours. At the same time, intelligence on Japanese positions was improving. Reconnaissance planes, coast watchers, and submarine patrols fed reports of troop movements and fortifications back to American planners. Commanders could identify which rivers posed the most serious challenges, where Japanese defenses were concentrated, and where engineering efforts would have maximum impact. Yet, even with this information, speed remained the decisive factor. Japanese troops expected delay. They counted on it. The faster an American unit could bridge a river, the more it would undermine Japanese assumptions and defensive preparations. Japanese forces, meanwhile, had underestimated the evolving capabilities of American engineers. Years of experience in static European and North African campaigns had left many commanders focused on frontal assaults and entrenched positions, rather than anticipating rapid technological solutions in jungle or island environments. River crossings, once predictable and hazardous, were no longer simple matters of waiting out the enemy or attempting fording under fire. The introduction of modular steel bridges, combined with pontoon flotation, meant that American forces could span rivers that had been considered natural fortifications. This evolving dynamic set the stage for dramatic encounters. For Japanese troops, every river crossing became a test of assumptions, morale, and adaptability. For American forces, rivers were transformed into tactical tools, symbols of both engineering ingenuity and operational speed. The stage was set for moments of shock and awe, when steel would outmatch nature and surprise would outmaneuver expectation. The realization of this technological and tactical edge did not happen overnight. It was the result of meticulous planning, training, and a relentless push for innovation under the pressures of global conflict. When Japanese troops first confronted these steel bridges, they were not merely seeing physical structures. They were witnessing the embodiment of American ingenuity and the psychological warfare embedded within it. The rivers, once shields, had become avenues for the advance, and the consequences of that transformation would be felt in blood, steel, and strategy alike. The tension at the riverbanks was palpable. Japanese units braced for delays that would never come, while American engineers prepared their materials with precision, aware that every bolt tightened, every pontoon secured, would directly determine the outcome of the coming engagements. The backbone of America's river-crossing advantage lay in logistics. By 1944, the United States had mastered the art of moving men, machinery, and material across vast distances in the Pacific, often under hostile conditions. Supply lines stretched across thousands of miles of ocean, linking California ports to island airfields, forward naval bases, and frontline units. These supply chains were not merely about food and ammunition. They delivered the tools that would redefine battlefield mobility: steel bridge components, pontoons, and mechanized equipment capable of rapid deployment. Engineer combat battalions were meticulously organized to capitalize on these advantages. Each battalion included specialized companies responsible for reconnaissance, bridging, and riverbank preparation. Soldiers drilled endlessly, assembling bridges in mock combat scenarios, learning to anticipate enemy fire, uneven riverbeds, and sudden changes in water levels. Speed was crucial. A bridge that could be assembled in a single day could transform a defensive riverline into a corridor for tanks, trucks, and artillery, allowing an entire offensive to surge forward before the enemy could react. Previous engagements had already demonstrated the value of such innovations. On New Guinea's Sepik and Ramu rivers, American engineers had executed rapid crossings under fire, earning the grudging respect of Japanese forces. In these operations, floating steel bridges had allowed tanks to roll across rivers that were previously thought impassable. Engineers worked with precise choreography. Pontoons floated into position, steel girders lowered, cables tightened, and within hours, entire divisions were advancing on the opposite bank. Each success reinforced the importance of combining engineering precision with battlefield timing. Meanwhile, Japanese forces continued to rely on static defensive measures. Fortified riverbanks, camouflaged machine gun nests, and hidden artillery positions had proven effective in slowing down slower-moving attacks. But they were increasingly inadequate against an opponent who could literally span rivers overnight. Reconnaissance often failed to detect the movement of bridge units, and the very speed of American deployments created confusion and panic among defenders. Where Japanese intelligence expected delay, it found mobility. Where it anticipated attrition, it faced the threat of encirclement. Leadership on both sides played a decisive role. American commanders, from battalion officers to theater strategists, emphasized coordination between engineering units and combat troops. Orders were precise. Engineers would deploy the bridge, infantry would secure the far bank, and armor would exploit the crossing. This integration ensured that bridges were not isolated tools but instruments of strategy, directly influencing the tempo of combat operations. Japanese commanders, in contrast, were often forced to react rather than anticipate. The sudden appearance of steel bridges disrupted prearranged defensive plans and created cascading logistical problems. Units intended to reinforce riverbanks found their routes blocked, positions flanked, and supply lines cut off. The psychological dimension was equally important. Japanese soldiers had been conditioned to see rivers as natural barriers. Their morale, confidence, and tactical calculations all depended on the assumption that crossing would be slow and costly. American engineers shattered that assumption. The first glimpses of steel bridges, gleaming under sunlight or moonlight, struck fear into troops who had trained for months to defend these natural choke points. Reports from forward units noted bewilderment. Troops hesitated, commanders cursed, and morale wavered. Steel, precision, and speed combined to create an almost surreal battlefield effect. By the time American units reached rivers like the Matanuca or the Lunga, the combination of reconnaissance, logistics, and engineered mobility had become a hallmark of their approach. Every bridge deployed carried not just men and material, but a message. The Japanese could no longer rely solely on terrain or natural obstacles. For American forces, the successful deployment of steel bridges over rivers was both a tactical triumph and a strategic signal, demonstrating that innovation and preparation could decisively shape the battlefield. In essence, rivers ceased to be static barriers. They became arenas where technology, training, and foresight converged. The upcoming encounters would test these principles to their limits. Japanese troops would confront not just the physical river, but the ingenuity and precision of an enemy that had turned water into a pathway for warfare. This sets the stage for the next sections, where we explore angles, human, technological, tactical, and leadership perspectives, showing how these crossings affected both sides on multiple levels. For the Japanese soldiers stationed along Pacific rivers, the first sight of American steel bridges was disorienting. These were men accustomed to relying on nature as an ally. Rivers, jungles, and swamps were their defensive friends. They had spent months, sometimes years, preparing ambushes, laying mines, and digging trenches, confident that the waterways would slow any enemy advance. Yet now, they watched in stunned silence as armored vehicles rolled across gleaming spans that seemed almost to appear overnight. Morale wavered. In personal accounts, some soldiers described feelings of disbelief and helplessness. The familiar rhythm of river defense, the calculated delay, the controlled fire, the expectation of attrition, was disrupted. Commanders, tasked with holding the line, faced anxiety and frustration as their troops questioned whether any barrier could truly stop the Americans. The human cost of this shock was immediate. Hesitation in firing positions, confusion over defensive priorities, and a subtle, yet palpable, erosion of confidence. This psychological edge amplified the physical advantage of the bridges. Where terrain once dictated the pace of battle, American ingenuity imposed a new rhythm. Soldiers found themselves reacting to movement rather than controlling it, and that shift, subtle but profound, shaped engagements long before bullets were fired. From a tactical perspective, the steel bridges fundamentally altered battlefield dynamics. Rivers, which traditionally served as natural choke points, now became avenues for rapid deployment. Infantry, artillery, and even tanks could cross in hours instead of days, rendering pre-established Japanese defensive lines vulnerable. Commanders who had meticulously planned for slow, methodical river crossings were suddenly forced to improvise. The bridges also allowed for greater operational flexibility. Units could bypass entrenched positions, threaten flanks, or rapidly reinforce forward elements. Artillery could be repositioned across the river with surprising speed, providing support that Japanese units had assumed would be delayed. Supply lines, previously restricted to narrow, precarious routes, expanded, allowing sustained offensives without the traditional pauses caused by natural barriers. In essence, the presence of American steel bridges forced Japanese commanders to reassess their strategies in real time. Defensive positions that once seemed impregnable became vulnerable to rapid maneuver, flanking attacks, and concentrated firepower. Tactical assumptions, based on months of experience and careful observation of terrain, were upended by engineering efficiency. The technological brilliance of the steel bridges lay not only in their design, but in their deployment. Modular steel sections, often prefabricated and transported via truck or landing craft, allowed engineer units to assemble robust, load-bearing structures in hours. Pontoon support provided stability in currents that would have washed away traditional wooden or rope constructions. Each bridge could bear the weight of tanks, artillery, and fully loaded supply trucks, turning rivers into temporary highways. American engineers relied on years of iterative development. Bailey bridges, reinforced with steel trusses and standardized components, were adaptable to varying river widths and depths. Floating pontoons offered resilience against shifting currents, while cables and anchoring systems ensured structural integrity under both weight and enemy fire. The precision of assembly was critical. One misaligned section could collapse under load, but trained units minimized these risks through drill, teamwork, and meticulous planning. From a broader perspective, the bridges were a tangible representation of American industrial power. Where Japanese forces had relied on static fortifications and natural obstacles, the United States leveraged technology to convert environmental challenges into operational advantages. Rivers that once dictated the pace and possibilities of warfare were now malleable, controlled, and predictable in a way that only disciplined engineering could achieve. These three angles, human, tactical, and technological, intersected at the riverbanks, creating a situation in which surprise, mobility, and ingenuity combined to shape the battle. Japanese troops confronted not just an enemy force, but an entirely new paradigm of warfare. Commanders, soldiers, and engineers all played roles in this unfolding drama, where steel, strategy, and human reaction were inseparably intertwined. At the heart of the river crossing operations was meticulous leadership. American commanders understood that speed and coordination were just as decisive as firepower. Battalion officers oversaw engineers and infantry alike, ensuring that bridges were not merely constructed, but integrated seamlessly into broader offensive plans. Timing was everything. Engineers could not work in isolation, and infantry could not advance until the far bank was secure. This required a blend of foresight, trust, and precise communication. Leaders dispatched reconnaissance teams to survey river conditions, adjusted plans based on tidal and current data, and coordinated artillery support to suppress enemy fire. The result was a choreography of movement. Bridges assembled, troops crossing, tanks rolling forward, all executed with a level of precision rarely matched in the chaos of combat. Decisions made at the command level had immediate and tangible effects. A single misjudgment in river depth, current strength, or enemy disposition could have delayed the crossing and endangered lives. The leadership philosophy emphasized initiative at lower levels as well. Sergeants and junior officers were trained to make rapid adjustments, improvising when pontoons shifted or enemy fire intensified. This decentralized decision-making allowed operations to continue smoothly even when communication lines were strained, a vital factor in the unpredictable conditions of Pacific River warfare. From the Japanese viewpoint, American steel bridges were almost surreal. Intelligence reports often underestimated the speed and efficiency of engineering units. Japanese troops, accustomed to seeing rivers as barriers, were confronted with the unsettling reality that an impassable obstacle could be traversed in hours. Observers noted the panic in forward units when tanks and artillery began appearing across rivers with little warning. Commanders on the Japanese side struggled to respond. Prearranged ambush points became irrelevant. Defensive trenches were flanked, and the anticipated delay never materialized. Units were forced to redeploy under pressure, often in confusion, which led to isolated engagements and unnecessary casualties. The psychological strain compounded material disadvantage. Soldiers were fighting not just the enemy, but the concept that natural obstacles could be rendered meaningless by American ingenuity. These encounters revealed a crucial gap in Japanese doctrine. While prepared for frontal assaults and jungle ambushes, defenders were ill-equipped to anticipate rapid, engineered solutions to environmental challenges. Each successful bridge crossing highlighted this mismatch, forcing a reactive rather than proactive approach and setting the stage for further American operational successes. Beyond tactical and operational implications, steel bridges carried profound psychological weight. For Japanese troops, the sight of American ingenuity defied expectations and introduced a subtle, persistent fear. Rivers, once a source of defensive confidence, became symbols of vulnerability. Each crossing demonstrated that the enemy could overcome natural obstacles with precision, speed, and organization. The moral effect extended to American forces as well. Soldiers gained confidence from witnessing the effectiveness of their engineering units, reinforcing trust in leadership, planning, and logistics. Confidence on one side contrasted with doubt on the other, creating a dynamic in which psychological advantage amplified physical capability. Engineers were not only constructing bridges, they were shaping perception, morale, and decision-making across the battlefield. In several engagements, reports indicate that Japanese hesitation allowed American forces to exploit crossings with minimal resistance. Soldiers delayed firing or retreated in disbelief, inadvertently granting momentum to the offensive. This interplay of perception and reality underscores a fundamental truth of warfare. Victory is determined not solely by weapons or numbers, but by the ability to manipulate conditions, expectations, and human reactions. It was March 1944, along the Matanacar River in Guadalcanal. Japanese defenders had prepared meticulously. Machine gun nests were concealed behind thick mangroves, snipers perched in elevated positions, and artillery pre-sighted to sweep any exposed riverbank. The river itself, swollen from recent rains, seemed a natural fortress. Commanders were confident that American forces would be delayed, attrition would take its toll, and the terrain would dictate the pace of battle. But American engineers had other plans. Just before dawn, reconnaissance patrols confirmed the river's current and depth. Bridge pontoons, pre-assembled and transported under the cover of night, floated silently into position. Infantry units, coordinated with precision, secured the near bank, creating a defensive perimeter around the assembly site. Then, with synchronized efficiency, steel sections were lowered, anchored, and locked into place. In less than 4 hours, A fully operational bridge spanned the river, capable of supporting tanks, artillery, and trucks. The first armored units rolled forward. Japanese defenders, initially believing it to be a temporary structure or camouflage, quickly realized the magnitude of the threat. Shock rippled through the lines. Machine gunners hesitated. Artillery crews struggled to adjust to the unexpected target, and small units found themselves outflanked before they could respond effectively. Reports from the field described soldiers stepping back in disbelief, murmuring about impossible engineering and questioning their own intelligence. The tactical impact was immediate. With tanks crossing the river, infantry could advance under armored cover, and artillery units were positioned to support the offensive without the delays that rivers had historically imposed. Japanese defensive positions crumbled under this combined pressure. Where a river once slowed the advance, it now became a corridor of momentum. Ambushes that had been meticulously planned were bypassed. Trenches and fortified lines were exposed from the flanks. Leadership on the American side ensured that the moment of shock translated into operational advantage. Commanders coordinated follow-up movements, bringing additional troops, supply convoys, and artillery across the river in rapid succession. Each unit reinforced the next, maintaining momentum and preventing Japanese forces from regrouping. Engineers, meanwhile, prepared secondary bridges, anticipating the need for multiple crossings, ensuring that logistical support would never be interrupted. From a human perspective, the scene was extraordinary. Japanese soldiers, facing what they had assumed to be impassable obstacles, found themselves reacting in real time to events they had no frame to anticipate. Confusion and fear slowed decision-making, while American forces moved with clarity and purpose. The bridge was not simply steel and wood. It was a psychological lever, magnifying the effect of every unit that crossed. By mid-morning, the first phase of the crossing had been completed. American infantry held the far bank. Tanks were positioned strategically to provide suppressive fire, and artillery units could shell Japanese positions with unprecedented range and accuracy. The river, once a natural defensive barrier, had been transformed into a conduit for American dominance. This decisive moment demonstrated a broader principle. Technological innovation, precise leadership, and coordinated execution could overcome even the most formidable natural obstacles. Japanese troops, trained and experienced, were forced into reactive positions, unable to anticipate the combination of speed, engineering, and operational coordination. Every second counted. Hesitation became costly, and every misjudged movement by the defenders compounded the advantage of the attackers. The first bridge at Matanakaw was only the beginning. Subsequent crossings along other rivers mirrored this pattern. Japanese forces, already stretched thin and fatigued from months of defensive operations, faced repeated shocks as American engineers replicated the success. Each bridge constructed was a tactical statement, each crossing an assertion of control over terrain that had been thought secure. As the morning light intensified, the riverbanks were no longer lines of defense. They had become stages for American operational dominance. Soldiers on both sides understood the stakes. For the Americans, the culmination of planning, logistics, and training was yielding tangible results. For the Japanese, the realization of vulnerability was immediate and disorienting. The balance of power in these engagements was shifting decisively and irreversibly. The second part of the climax will follow the subsequent engagements, Japanese reactions, and the full operational consequences of these river crossings, leading directly into the aftermath. The hours following the initial crossing over the Matanakaw River were a crucible of chaos and coordination. Japanese defenders, initially paralyzed by disbelief, scrambled to organize counterattacks. Sniper teams attempted to target engineers on the bridges. Artillery crews shifted fire to halt the advance, and small infantry units tried to cut supply lines. Yet the American response was relentless and precise. Each bridge was reinforced with additional pontoons, infantry squads provided protective cover, and artillery suppressed key enemy positions with meticulous timing. By late morning, the full weight of the American offensive had reached the far bank. Tanks, trucks, and supply convoys poured across the steel span, establishing a formidable beachhead. Japanese units, forced into reactive positions, were outmaneuvered repeatedly. Traditional defensive tactics, ambushes, mines, and fortified trenches were neutralized by rapid crossings and flanking movements. Commanders on both sides understood the psychological as well as the tactical stakes. The Americans leveraged speed and engineering not merely to cross rivers, but to dictate the tempo and narrative of the battlefield. The impact was felt most acutely in troop morale. Japanese soldiers reported confusion and panic in field journals and post-war accounts. Hesitation in firing, miscommunication between units, and retreat under pressure became common. Even seasoned veterans, who had survived months of jungle warfare, found themselves unnerved by the ease with which Americans overcame natural defenses. The bridges were not just obstacles surmounted. They were symbols of an unstoppable logistical and technological force. American leadership capitalized on this momentum. Commanders dispatched additional bridging units to nearby rivers, anticipating future crossings. Engineers moved quickly to construct secondary and tertiary spans, ensuring that logistics, reinforcements, and supplies could flow without interruption. Infantry and armor coordinated to exploit each crossing immediately, striking Japanese positions before defenders could reorganize. The synchronization of engineering, infantry, and artillery created a cascading effect. One successful crossing triggered operational advantages across the theater. Tactical reports from this period highlight the devastating efficiency of these operations. In several engagements, Japanese units attempting to retreat were cut off by tanks already positioned on the far bank. Artillery units that once required days to redeploy were now operational within hours. Each bridge became a force multiplier, magnifying the effectiveness of every American unit in contact with the enemy. The rivers, once thought to provide natural delay and protection, became conduits for overwhelming force. The technological triumph was equally undeniable. The steel bridges, modular and resilient, could support the heaviest tanks deployed in the theater. Engineers demonstrated the capacity to repair or replace damaged sections under fire, maintaining continuity in operations. For Japanese observers, these structures seemed almost indestructible, defying both expectation and conventional warfare logic. The combination of reliability, speed, and load-bearing capacity transformed rivers from obstacles into strategic tools that reshaped the battlefield in real time. By late afternoon, the cumulative effect was evident. Japanese defensive lines along multiple rivers had been breached, supply routes disrupted, and command cohesion eroded. The psychological shock translated into tangible losses. Isolated units were encircled, reinforcements arrived too late, and the defenders' confidence in the natural barriers they had trusted for months was shattered. American forces, conversely, maintained momentum, consolidating gains, and pressing forward with the assurance that rivers were no longer limiting factors. This period marked a pivotal turning point in the Pacific campaigns. The successful deployment of steel bridges did more than facilitate movement. It shifted the strategic paradigm. Japanese forces could no longer rely on terrain alone to delay or repel American advances. Every river crossing became a demonstration of industrial, technological, and operational superiority, reinforcing the broader momentum of the Allied offensive. The conclusion of these river-crossing operations naturally leads into the aftermath, where the consequences of rapid American mobility, Japanese disarray, and the psychological impact of steel bridges are fully realized. Commanders, soldiers, and engineers alike would feel the reverberations of these decisive moments long after the rivers had been crossed. The immediate consequences of the American steel bridge operations along the Matanikaw and other rivers were striking. Japanese defensive positions, once considered nearly impregnable due to the natural barriers they relied upon, were systematically bypassed or neutralized. Units that had prepared months of entrenchments found themselves outflanked, exposed, and increasingly isolated. Where rivers had long dictated the tempo of Pacific battles, the American crossings imposed a new rhythm: swift, coordinated, and relentless. Casualty reports reflect the effectiveness of this shift. In multiple engagements, Japanese losses increased not solely from direct fire, but from disorganization and miscalculation. Soldiers attempting to reposition or retreat across exposed terrain were caught by advancing infantry and armored units already on the far banks. Field journals describe confusion and disbelief as entrenched units collapsed under attacks they had assumed would be delayed by geography. Conversely, American casualties were comparatively low, a testament to the careful planning, timing, and protective measures incorporated into bridge deployment and follow-up operations. Logistics, previously a limiting factor in riverine assaults, became a decisive advantage. Bridges allowed the uninterrupted flow of supplies, artillery, and reinforcements. Fuel trucks, ammunition convoys, and field hospitals could move across rivers without pause, sustaining the offensive and enabling a continuous push against Japanese positions. In effect, the bridges transformed what had been geographic obstacles into conduits of operational power, multiplying the effectiveness of every unit in contact with the enemy. The human impact extended beyond physical losses. Japanese troops experienced a significant erosion of morale. Soldiers who had relied on rivers as protective barriers were confronted with the unsettling reality that nature could be overcome with speed and engineering. Commanders faced frustration as meticulously planned ambushes and defensive lines became obsolete overnight. Hesitation and miscommunication became commonplace, amplifying the effectiveness of American operations. American engineers, on the other hand, received recognition for their decisive contribution. Field reports and after-action reviews highlighted the precision, discipline, and ingenuity required to assemble steel bridges under fire. Leaders emphasized that the success of the crossings depended not only on materials and training, but on coordination, timing, and trust between combat and engineering units. The bridges were as much a psychological weapon as a physical one, shaping perceptions and decisions on both sides of the river. The operational lessons were immediate. River crossings could no longer be treated as slow, high-risk maneuvers vulnerable to attrition. With proper preparation and execution, rivers could facilitate rapid deployment, flanking, and supply, altering the strategic landscape. For Japanese forces, the encounters underscored a critical vulnerability. Reliance on static natural defenses without anticipating technological solutions left them exposed to rapid, decisive action. The cumulative effect of these river crossings extended beyond single engagements. American momentum in the Pacific theater was reinforced by the psychological and logistical advantages the bridges conferred. Troop movements accelerated, supply chains became more reliable, and the ability to exploit enemy weaknesses expanded. Commanders could plan offensives with the confidence that rivers would no longer impede progress, allowing for more ambitious operations and concentrated attacks on strategic objectives. In the weeks and months following the Matanikaw River crossings, the strategic implications of American steel bridge operations became increasingly evident. Japanese commanders were forced to reassess defensive doctrines across the Pacific. The assumption that rivers and other natural barriers would slow or halt American advances was no longer valid. Across Guadalcanal, New Guinea, and other contested islands. The sudden mobility granted by these bridges allowed U.S. forces to strike unexpectedly, envelop defensive positions, and maintain relentless pressure on enemy units. The operational tempo of American forces accelerated. Infantry and armor could now be repositioned rapidly. Supply convoys moved without interruption, and artillery units deployed across multiple fronts with minimal delay. Bridges enabled not only the advance of frontline troops, but also ensured that logistical support kept pace with offensive operations. Units that had previously been limited by river crossings were now capable of continuous, coordinated assaults, reducing the time Japanese forces had to prepare countermeasures. Japanese troops, already stretched thin, struggled to adapt. Reports indicate that defensive planning became increasingly reactive. Commanders attempted to fortify areas beyond rivers, anticipating that the Americans would attempt multiple crossings, but the scale and speed of bridge deployment often outpaced their adjustments. Morale suffered as soldiers confronted the reality that terrain no longer guaranteed security. Hesitation and uncertainty pervaded units, and even seasoned troops reported feelings of disillusionment in field diaries. The broader strategic effect extended to entire campaigns. Islands that had been considered formidable due to natural river barriers and jungle obstacles were now accessible. American planners could implement operational strategies that relied on rapid, multi-directional assaults, flanking movements, and supply efficiency. Engineers became central to planning, not auxiliary. Their ability to transform rivers into highways altered the calculus of both offensive and defensive operations. The psychological impact cannot be overstated. Steel bridges became symbols of American ingenuity, industrial capacity, and adaptability. They demonstrated that technological solutions could overcome the natural and man-made obstacles that had traditionally shaped warfare. Japanese commanders and soldiers alike understood that the effectiveness of rivers as defensive lines had been fundamentally compromised. The perception of invincibility tied to terrain was replaced by an awareness of vulnerability, a shift that had long-term implications for morale and operational planning. Even beyond immediate combat zones, the lessons from these crossings informed Allied strategy across the Pacific. Engineers were increasingly integrated into operational planning, and bridge-building units became critical assets in island-hopping campaigns. The efficiency and speed of river crossings allowed planners to take risks previously considered untenable, striking at key Japanese positions before they could be reinforced. In essence, steel bridges reshaped both tactical engagements and strategic decision-making. The aftermath of these river operations underscores a central truth of the Pacific War. Victory depended not solely on firepower or troop numbers, but on the ability to combine innovation, coordination, and psychological impact. The American use of steel bridges exemplified this principle. Physical obstacles were transformed into instruments of advantage. Human reactions were influenced before a shot was fired, and the momentum of the battlefield increasingly favored the technologically and logistically superior force. As the rivers were crossed and Japanese positions fell, the significance of these operations extended beyond the immediate tactical gains. They became emblematic of a new form of warfare, one in which industrial capacity, engineering expertise, and careful planning could decisively shape outcomes, turning what had been natural defenses into conduits of attack and leaving an indelible mark on the Pacific campaigns. The image of steel bridges spanning rivers in the Pacific remains a powerful symbol of ingenuity, preparation, and the human capacity to reshape the battlefield. These bridges were more than engineering feats. They were instruments of strategy, psychological leverage, and operational momentum. Where nature had once dictated the pace of warfare, American forces imposed their own rhythm, swift, coordinated, and decisive. In the broader context of World War II, These river crossings illustrate the evolving nature of conflict. Victory was no longer determined solely by numbers or weaponry, but by the ability to integrate technology, logistics, and leadership into a cohesive whole. The bridges transformed rivers from barriers into pathways, turning Japanese assumptions about defensive geography on their head. Soldiers faced a lesson that would echo across the theater. No terrain, however imposing, could substitute for foresight, training, and adaptability. Yet the human dimension remained central. Japanese troops confronted not merely steel and strategy, but the psychological shock of an enemy who could overcome what had long been considered inviolable. American soldiers, engineers, and commanders experienced the quiet confidence that comes from precision, preparation, and trust in one another. In this interplay of human perception, skill, and technology, the outcome of battles was shaped as much in minds as on riverbanks. The legacy of these operations extends beyond the immediate conflict. They highlight the transformative role of engineering in warfare and the subtle power of morale and perception in determining outcomes. The lessons of the steel bridges reverberate through military history. Ingenuity and coordination can overcome natural obstacles, and the edge gained through preparation and innovation can tip the scales of war. In the end, the rivers of the Pacific were crossed not only by men and machines, but by ideas of speed, adaptability, and technological mastery. In the fog of jungle and mist, where Japanese defenders once saw safety, the gleam of steel signaled a new reality. It was a moment that encapsulated the convergence of human courage, mechanical innovation, and strategic vision, a quiet turning point whose effects would shape the course of the war and remain a testament to the ingenuity that defines human conflict.